Hello everyone, welcome to this talk on cost-effective log management using Elastic. We're going to talk about faster, more affordable log management and analytics today. Before we dive in, let me give you a quick overview of what we're going to cover today. We're going to start with the problem statement, some of the challenges that you typically have when dealing with log data. Then we're going to do a quick detour and talk about how search actually works under the hood, what makes it fast, what makes it work, because that's important for the next topic on the agenda here, which is data tiering. How can we store this data cost effectively? And finally, we're then going to wrap it up with a demo showing all of those capabilities in action, because I think that's always the best way to explain things. So let's get started. The problem first. If we talk about logging and log management, I think we can all agree that logs are incredibly useful for giving us early warning signs of potential issues, or even pinpointing what exactly went wrong. In addition, they can definitely help with the problem resolution. They allow us to find what exactly happened. They allow us to understand the problem in lots and lots of detail. Now, unfortunately, log traffic is growing exponentially. As you might be aware in your organization as well, you have more and more logs that are getting more and more complex as well. Everything just seems to be logging more, and we would like to have additional visibility into these systems. The challenge here is obviously that things might get expensive. You need additional servers, you need additional disk space, additional storage somewhere for all of this data and all of your logs. And like I said, the complexity is definitely a challenge too. You have so many systems, so many servers, so many applications. So you need a tool that's able to search everything in a single place while overcoming some of these challenges. So in addition to exponentially growing costs, another common problem is also that access to historical data is really slow. You might be storing your really old logs in a completely separate system, or maybe your organization actually stores the log file in their raw format somewhere, which prevents you from using Elastic on them at all. Some of you might even have fragmented observability solutions, either for the different types of observability when it comes to metric data, log data, and tracing data, or you might have different systems for short and long-term access. Maybe you have the most recent data in Elastic, but then use a completely separate system for searching your older data that's, let's say, more than a month old. Today, I want to show you how Elastic can handle all of this. Let's look at some of these things in more detail. When I talk about cost-effective data retention, there's a few individual things that we can address directly. Let me give you a few examples here. The data obviously needs to be stored for a long time, sometimes even for years, for compliance reasons. How do we do this? Well, we have this concept called data tiers, so you can get the most value from the hardware depending on how you actually use this data. And we're going to cover data tiers in much more detail in a few minutes from now. The next problem that you might encounter is that SSDs and CPUs are expensive. So having really fast access to this data can become quite challenging from an economics perspective. Things get expensive if you only buy SSDs and try to store your data only on this SSD storage. So what Elastic can provide you as well is this cost-effective long-term storage using a simple blob store such as S3. Finally, cheaper storage is oftentimes magnitudes slower than a local SSD would be. How can we solve this? Elastic has very optimized data structures for this data access, and we'll talk a bit about these as well to make you understand how everything fits together. But using these pre-built data structures, we only have to look at a fraction of the data, so we can handle these slower storage systems as well. And then lastly, some solutions that you might be using today have this need to rehydrate data, which means that if you want to search something that's really, really old, it needs additional manual steps, or you even need to call someone to do this job for you. But with Elastic, we have this seamless user experience for you. Everything looks and feels the same no matter how old the data is. It could be data that's stored just recently, could be data that's a year old. It should all be accessible seamlessly, and I'll show you a little bit of that in a few minutes from now. Before we talk about how we store the data and how we can search this data, let's take a step back here and talk about how search actually works under the hood. We obviously won't have time to talk about every single detail here, but I do want to show you one general concept that we're using to make our search both fast and more efficient. And in turn, that will then also help us achieve this cost-effective storage down the road. Let's start with a very simple example here. Imagine that you have a book in front of you about databases. It's a book about databases. It has about 1,000 pages, and you would like to read about the topic of data types in this database. So what you would have to do now, if you only have this book, is you would have to look through 1,000 pages to find that answer, to find that topic about data types. It's going to take you a while to complete. If you're smart, you might start at the back of the book, as it typically has what's called an index, a dictionary, a list of all of the topics or terms that are covered in the book. If you take a look here, data types are mentioned on pages 80 and pages 93. What does this mean for you? Well, instead of reading 1,000 pages, you just have to read a few pages now. And if I now ask you that same question again, tell me something about data types that's written in this book, instead of reading all of those individual pages, everything that's green here in this illustration, you really just want to check the terms index at the back of the book and then read the corresponding page. And with Elasticsearch, it's pretty much the same thing. So instead of looking at the raw data that you store in the system, we typically only look at a few optimized data structures depending on the questions that you ask Elasticsearch. And that obviously significantly reduces the disk size, or rather the size of the data that we need to inspect when a query is, or an aggregation is being executed. And we'll see later how this comes in handy when we talk about cost-effective and also, most importantly, fast search. One additional advantage of all of this is if you, let's say, have a log file with a raw size of 20 gigabytes of data, and 6 of these log messages have the term error 123 for user John. If you now search for the term error here, we don't need to look at the raw size of 20 gigabytes. Instead, we just need to check which documents contain the term error, which in our case could be documents number 1, 63, 212, and so on. And we just need to inspect these individual documents and return these back to you compared to looking at all of this data on disk. And that brings us to our next topic, which are data tiers. What are data tiers? Some of you might have been using Elastic for a longer time and are already familiar with some of these concepts here. Elasticsearch typically has these 4 data tiers to offer, and it doesn't matter if you're using us in Elastic Cloud, on-premise, or really anywhere else. You have these 4 data tiers to choose from. You can have a hot node that we typically see used for the last 7 days of data. That's for the most recent data that you want to access in the quickest way possible. Typically, this hardware would have local SSDs and lots of CPUs to process the data. The next node type then is warm for still real-time storage, but also a bit longer term. So typically what we see is like 7 to 30 days. Data here is stored on HDDs, so spinning disks. Much slower, but also more economical, since HDDs have a higher storage capacity at a lower cost. Similar for the cold storage, where we typically see customers storing the data for up to 90 days. And then lastly, we have the frozen nodes. These frozen nodes are often used to store the data forever. Data here is not stored locally on disk. It's not on an SSD, not on an HDD. Instead, it's stored in some kind of a blob storage, S3 or similar. And using this bucket storage makes it really economical, and I'll have some numbers for you at the end as well. The great thing that you can do now is you can really decide how you would like to store this data on these nodes. So you have the full flexibility to decide, okay, how long do I want to store my Windows logs? How long do I need my system metrics? How long do I need my debug logs? And this is fully customizable to you for any individual data source that you collect using a very simple setup in the UI. And I'll have a brief demo for this as well. And this full flexibility then allows you to take advantage of each of these tiers in the best way possible. So we don't restrict you to set the retention period to the same value for every data source. Instead, you have this flexibility to decide what works best for you and your organization. When we talk about search, this search experience is also the same across all of this. We don't have any rehydration or any other manual steps. In fact, if you search something in Kibana, what we would like to have for you as a user is that you can't even tell if you're hitting a hot node, a warm node, a cold node, or a frozen node, because it really should not make a difference for you as the end user. The only thing that you might be noticing is that searching some of these node types to the right-hand side here is getting a bit slower than searching on the hot nodes. Now, one important point I want to make here again is that this frozen node type that we have here, it might have a bit of an unfortunate name. Frozen is often used in the concept of actually frozen data where it's not really accessible. For Elastic, it's still fully part of your cluster. It's still fully searchable, fully analyzable, so you can still use it using the same functionality as you can on the hot nodes, for example. Looking at this frozen node in a bit more detail, the reason why we can provide efficient search across so much data on a single node is because of these data structures that I mentioned before. Remember how I said if you want to read a book or read about a specific topic in that book, you don't actually have to look through the whole book if you'd use that index? Well, Elasticsearch does the same thing on the frozen nodes as well. So instead of fetching the whole raw data from this bucket, we just fetch what we actually need. It could be specific fields, it could be specific indices for these fields, whatever makes the most sense, whatever is the least amount of data possible. So we fetch this data, save it locally to a cache, and if you run a similar query again, the access is much faster since it's already cached. This then in turn gives you many, many advantages. Much lower hardware cost, much lower object storage, API usage cost, and data transfer cost. Since we don't have to access the raw data, we just need to fetch a few specific things from this object storage. One huge advantage that you will also have if you use these frozen nodes is that typically for most of you, you would have more than a single data source stored in Elasticsearch. And the advantage then is that you can already select in Kibana what you would like to search, thereby reducing the amount of data that we have to look through significantly. So imagine you have Nginx logs, system logs, some application logs, traces and metrics, and much more in your cluster. If you want to search something and go back a few years with that search, you would typically start by selecting one of these data sources. So let's say I want to search my application logs. And another factor that makes this search very fast as well is that you would usually also have some kind of a time component to this. You would only be searching back 7 days or 30 days, or looking for a specific point in time where something happened in your infrastructure. You might have had a security incident, and you want to review the logs of that specific day. So using these index structures that we have, your indices are usually grouped into smaller chunks by having them roll over on a certain size. And we'll talk briefly about index lifecycle management as part of this demo here. In turn then, really what we have to do if you ask us about application logs that happened on a specific day in the past is we only have to look at a tiny chunk of your data. We don't have to look at everything, we just have to look at this and then also use the optimized data structures that we talked about earlier. Going back to this cost-effective part again, I mentioned that I would like to talk about pricing a bit as well. So how do these tiers actually compare? Quick illustration here with an approximation on cost. If you store the same data dataset size on a hot node, it would cost you about $100. If you stored a similar amount of data on a warm node, that would be about $37, followed by $18 on a cold node, or just $1.50 on a frozen node. You can look up this pricing at cloud.elastic.co/pricing if you want to make a similar comparison for your datasets. But really what I want to emphasize here is that this frozen object level storage, blob stores, are just so much cheaper than local SSDs. And if you think about your data access patterns, most of your data probably just lies around on disk and you don't actually use it too much day to day. But you still want to have that searchable. You still want to have that available. So utilizing these frozen nodes can be really powerful to have cost-effective data retention. Let's now get into the demo. I want to show you how you can use these data tiers and how you can also then use them from Kibana, hopefully without noticing that you are hitting different tiers while you are searching. We're now looking at Kibana here, and I want to start by quickly telling you about my setup here. So I have the Elastic Stack set up, and I have a few services logging data into the system. I've configured it to roll over this index when it's older than 10 minutes, and once the index is older than 20 minutes, I will then move it into this frozen phase. Please don't take this as a recommendation. This is purely just for demo purposes. You would never ever roll over your index after 10 minutes. Typically, you would look at the index size or at the shard size and roll it over based on that. So please do not change your ILM policies to flip it every 10 minutes. That's definitely not recommended. So what does this mean for us? Well, after 10 minutes, it rolls over the first time, and then 20 minutes after that, we move it into frozen. We're now looking at a logs dashboard here. We have some log messages to the bottom right here, some services over time, how much logs they have, log levels up here, and then to the bottom left here, we have our index names. If I change the time here to the last 30 minutes, what we'll be able to see is that every 10 minutes we have a new index, because that's what we configured index lifecycle management to. If I look at 1 hour of data, what we can then also see is that we're starting to have these indices called partial. Partial in this case means that they are currently mounted on a frozen node. So they don't use any disk space anymore. They're just mounted from that backup, from that snapshot repository using S3 or similar. And if I just go back further here, let's maybe look at the last 96 hours in comparison. We can see how it's just loading our dashboard as it usually would. It's getting a little bit slower, but you can see here that we have these partial indices, and this is also all just mounted, but the dashboard functions very much the same way as it did before. In fact, I can search and filter this frozen data as I could any other data source on my hot nodes as well. So drilling this down to a specific time window and a specific service name just loads all of my visualizations in the same way that I'm used to. I can zoom down further here if I wanted to, and you can see how fast this is. So even though I'm using this bucket storage right now, this is very responsive since this frozen node does some local caching as well. If I just go back again 2 times here to get this longer view, what I can also do is I can use the full text search functionality of Elasticsearch as well. So really, I'm not limited to anything here. Let me maybe just remove this filter here as well. Let's search for Postgres. Maybe something happened to my Postgres database. Didn't find anything here, so let's maybe change this to the last 7 days. See if we had anything happening for Postgres back then. You can see same UX as you're used to, but only 20 minutes or so or 30 minutes of the data is actually stored on SSDs. The rest is just stored in some kind of a snapshot bucket somewhere else. And lastly, let me quickly show you the monitoring data of this cluster as well. I'm currently using only a 4 GB heap node in Elastic Cloud. That's the smallest frozen node that we have available. And this node allows me to search 6 terabytes of data. It's quite a lot. If we look at this node in a bit more detail, we can also see that it has all of this data mounted to itself without using any of the disk space. So as we can see, data is 0.0 bytes, and if I scroll down, we can see that it has all of those partial indices assigned to it, which means that they are mounted. You can also see the time when we executed our searches. The CPU briefly spiked up, but then it went down again after the search was completed. Because in its idle state, a frozen node really isn't doing a whole lot, since it just has this read-only mode, so to speak. And that's it. I hope that you enjoyed this quick talk and demo around cost-effective log management. So main takeaways here: try to take a look at the frozen tier. It's really cost-effective, it's really easy to use, and it can perform quite well depending on how your data is structured and how you access your data. I hope you're having a good rest of the